Hello everybody! So we are back today, and today we are going to be looking at applications of these areas and volumes questions in an AP context. So we would like for you to see the types of questions the AP test might ask you to do and how you would approach those. We decided to do one full AP test question together in this video, and then we'll spend the next couple days practicing this in class. Now, on the AP test, when this was originally given as a question, this was a no calculator question. So we're going to go ahead and try to work through this, again, with no calculator. Part 1 says, let R be the region bounded by the x-axis, the graph of y equals the square root of x, and the line x equals 4. Find the area of region R. So I like to sketch a picture for these. I think it helps me visualize what's going on. Honestly, I'm not really sure who could do this without a picture, so I would strongly suggest that we sketch a picture. Now, it doesn't have to be a great picture. It could just be something to represent the problem. So I know that the x-axis is one of my boundaries, as is the graph of y equals the square root of x. And the line x equals 4, which is a vertical line. Which means the area that they're talking about is this area here. Now, if I'm trying to decide how to find that area, what I'm really doing in my head is debating between integrating with respect to x and integrating with respect to y. In this case, we could do the problem either way. I would suggest integrating with respect to x simply because the equation is already written where y is by itself. So to do this integral, I would say that the area equals the integral from my beginning x, which is 0, to my ending x, which is 4. And inside of here, I need to do top minus bottom. Now the top of my area is going to be on the graph of y equals the square root of x. So I would write the square root of x here, minus the bottom of my area would be 0. dx, because I'm doing this problem with respect to x. Now, again, this is no calculator, so our next step would be to simplify this integral as much as I can. So I would have 0 to 4 of the square root of x dx. Now I'm going to need to do the antiderivative. Now the square root of x is really x to the 1/2. So I would add 1, which would give me 3/2, and then divide by 3/2, which would give me 2/3 for the antiderivative, plus c from 0 to 4. Now I'm going to plug in my top number first. So 2/3 times 4 to the 3/2 plus c, minus 2/3 times, there we go, 0 to the 3/2 plus c. Now the plus c's are going to cancel, and 0 to the 3/2 is 0, so this is worth 0. Really what I'm left with here is evaluating 2/3 times 4 to the 3/2. Now to do that, what I'm going to do is square root the 4 first, which gives me 2. Then cube it, which gives me 8. So I'm going to have 2/3 times 8, which would be 16/3 for my area. Part B of this problem says, find the value of h such that the vertical line x equals h divides this region into two regions of equal area. Again, I think sketching a picture for this can be really helpful. So once again, I'm going to draw my region, which now we know ends at 4. I want to draw a vertical line, x equals h, so that the area on the left and the area on the right are equal. Now I already know that the total area is 16/3. So in other words, I want the area here and the area here to both be worth 8/3. To do this, I'm going to set up an integral. In order for this area to be 8/3, I would need the integral from 0 to h of my function, which is top minus bottom, so square root of x dx, to equal 8/3. Now, the reason this problem is a little bit different than what we already did was that in the previous problem, we knew both of the bounds and we were finding the area. Here, we're missing one of the bounds, but we know what we want the area to be. So, we're going to deal with the left side of this equation first. Just like before, the antiderivative of the square root of x would be 2/3 x to the 3/2 plus c, evaluated between 0 and h. And we know we want that to equal 8/3. Now if I plug in my h and my 0, I'm going to have 2/3 h to the 3/2 plus c minus 0 to the 3/2 times 2/3 plus c. And I want that to equal 8/3. Once again, the c's cancel, and this is worth 0. So the equation that I'm really trying to solve is 2/3 h to the 3/2 equals 8/3. Now, what I'm going to do to solve this, just like I would solve any equation, is try to get h by itself. So I'm going to start by dividing by 2/3. Now, dividing by 2/3 is the same thing as multiplying by 3/2. So what we end up with here is 4. Now, in order to get the h by itself, I'm going to raise both sides to the 2/3 power. Because 2/3 times 3/2 makes 1. And my final answer would be 16, the cube root of 16, because it would be 4 squared and then cube root it. Now part C says, find the volume of the solid generated when R is revolved around the x-axis. So now what we're going to be doing, and again I'm going to sketch a picture, is we're going to be taking our area that we did in part A, and we're going to be revolving it around the x-axis. Now as soon as I see that I'm revolving around the x-axis, I know I'm doing this problem with respect to x. The mirror image of this area would be down here. Okay, and if I wanted to draw in one oval, like at the edge, to see, it would look kind of like a cone. All right, now, my first step is to identify my cross sections. Whenever we're revolving, our cross section area formula is always pi r squared. Our second step would be to figure out, well, what is r? Well, in this case, r would be top minus bottom, so it would be the square root of x minus 0. And our third step would be to set up our integral. Now this simplifies to the square root of x, and our integral will go from 0 to 4. We're going to have pi times r, which is the square root of x, squared dx. So before I try to evaluate this, I'm going to simplify the integral. So I'm going to have the integral from 0 to 4 of pi times the square root of x squared is just x, dx. I'm going to pull out the pi. I think it makes it easier to evaluate because pi's can be kind of tricky for numbers because it's not very nice if you don't have a calculator. Now the antiderivative of x would be 1/2 x squared plus c evaluated between 0 and 4. I'm going to plug in the 4 first, so I'm going to have 1/2 times 4 squared plus c minus 1/2 times 0 squared plus c. The c's are going to cancel and this is worth 0. Now 4 squared is 16, half of that is 8, times pi gives me that my volume is 8 pi. In part D, it says, the vertical line x equals k divides region R into 2 regions, so that when these 2 regions are revolved around the x-axis, they generate solids with equal volumes. Find the value of k. Now what we're doing is very similar to part B, where we were splitting up our area into equal areas, but this time we're trying to figure out how to split up our volumes into equal volumes. So I'm going to, again, sketch a picture. I think that can be very helpful. We're taking this area and we are revolving it to make a volume. But we're going to draw a vertical line somewhere on this graph so that the volume on the left and the volume on the right are the same. Now our total volume from part C was 8 pi, so that means that the volume here should be 4 pi and the volume here should be 4 pi, because that would be splitting it in half. So if I set up an integral to figure this out, I know all of my cross sections are still going to be circles, so I'm going to have my area is pi r squared, and I know that my radius in this first section is still going to be top minus bottom, so it's still going to be square root of x minus 0. But when I set up my integral, I'm going to integrate from 0 to k. I don't know that end bound. And then I'm going to have pi times my radius, which is the square root of x, squared dx. And I know I want this integral to equal 4 pi. So in a similar way to the way we did the area problem, we're going to be solving for k. We want to find k. So again, I'm going to simplify the integral, and I'm going to have the integral from 0 to k of pi times square root of x squared is just x, and we want that to equal 4 pi. I'm going to pull out the pi, I'm going to do the antiderivative, and now I'm going to work on evaluating that integral. So I'm going to have pi times, if I plug in k, I have 1/2 k squared plus c, minus, if I plug in 0, I have just c, and I want this to equal 4 pi. The c's are going to cancel, so I have 1/2 pi k squared equals 4 pi. Now I'm going to again try to find k. So I'm going to divide by the pi, and that's going to cancel. I'm going to divide by 1/2, and I'm going to get k squared equals 8. So when I square root this, I get plus or minus the square root of 8. Now in this situation, because x equals k needs to be on the positive side of the x-axis, I know that my k value must actually equal the positive square root of 8 only. Alright, that's it. We are going to practice these style of questions for the next several days in class. Thank you guys so much for watching, and have a great afternoon.